Okay. Point your eyes at this. I've got a 1 kilogram mass. I'm about to hang it on this force scale. And 1 kilogram weighs how much on the surface of Earth? It weighs nothing in space. It would just float there. It would be like right there. But on the surface of the Earth, it should weigh what? 9.8 newtons. And if you said 1 kilogram, you are a nilly. Okay? Because it cannot weigh kilograms. It can only weigh newtons or pounds, but it has a mass of 1 kilogram, right? So there's a big. So what does it read? Yeah, it's close enough to 9.8 that I'm willing to believe that there's some agreement between this mass and this thing's force, right? Now, if we look at this thing, what if I make this thing accelerate upward? What's the force going to be? Greater than 9.8, right? So let's just see. It's like, whoa, there. You see when I was accelerating it up that the force got bigger than that. Watch again. It's like, right? Okay. Now, there are two ways to accelerate up. One way is to start going up. That's the obvious way, right? What's the other way? Slowing down, going down. So watch this. As I stop going down, watch the force. You see that? When I stopped going down, it also went up. Yeah? Okay. So there are two ways to make the force greater than the weight. One way is, yeah, it's just the inertia, right? So basically the one way to think about it is that the force on there is the force needed to hold it against gravity plus the force needed to accelerate it, right? Okay, so if I accelerate up, it's more force. If I accelerate down, it's less force, yeah? In fact, watch the needle. When I accelerate down, what does the needle do? It gets less, right? And in fact, if I just let it drop, it goes to zero, right? It's essentially like weightless, right? Okay, now there are two ways to accelerate down. What are they? One way is to start going down, which is this, right? The other way is that I'm going up and I stop going up, right? Isn't that also a downward acceleration? Okay, so it's like there. Do you see when I reach the top, it also reached close to zero? Watch again. It's like, there you go, yeah? Now, we know this because we ride elevators, yes? And in the elevator, when the elevator starts going up, it's like you feel heavy, yes? Right? Or when it stops going down, you feel heavy. You feel heavier than you normally would, yes? Okay. How about when it starts to go down or stops going up? What do we feel? Lighter. We feel a bit lighter, don't we? Right? So you've always had, people like you jump in the elevator. When do you jump? Well, when the thing starts going down, or equally when it stops going up. In fact, sometimes some elevators actually give you less of a G. They give you more of a G force when they stop going up than when they start going down. I don't know why that is. Okay. Now, how high can you jump? Well, in an elevator that is stopping going up or starting to go down, that is when you feel light, okay, you can jump quite high. In fact, I was in some high-rise building that had the really aggressive elevators, and I tried to jump as high as I could on the elevator. Well, I can't, I can jump like a foot or something like that. My vert, is like 12 inches, 11 inches, not quite, right? Okay. So on the elevator, I jump as hard as I can, and I ram my head into the ceiling of the elevator, right? Now, the reason it stopped was that somebody had pressed a button. They wanted to get on the elevator, yes? Okay? And it was moving up when it stopped. I jumped, I ran my head into the top, and then I'm like, and you do that thing where it's like, am I bleeding? Right? And I was not gushing blood, but I was enough blood so my hand was red. Right? So I'm like, looking at my hand, and the nice gentleman that was going to get on the elevator chose not to get on the elevator. Right? It was like, I get on the elevator with a guy that has a scalp wound. Now I'll wait for the next one, there's no easy, there's no not awkward way to not get on the elevator, right? It's like, wait for the next one, What do you say? It's like, so, let's keep this in mind. Let's suppose that you are climbing, yes? Climbing ropes can support, and by the way, after the BSEP class, I will know exactly how much they can climb, but they can support many times your weight. Let's say 100 times your weight. Why do they have to be so strong? Weight, the extra strength makes the ropes heavy, right? Don't you just need a rope that can support your weight or maybe the weight of a heavy person? No, they can support hundreds of times your weight, right? Why is that? Well, because what you do is you're going to fall, right? You go up the rock, right? And you put in these little points of protection like this, right? This thing goes into a crack in the rock, right? You put a carabiner over that. You put the rope through the carabiner. You climb another 10 or 15 feet, right? You put another point of protection in there. The person at the bottom is taking these out of the rock and putting them on their belt, right? I guess at some point you got to I don't know, I'll learn, right? Okay. But anyway, when you fall, if you're 15 feet above this and you fall, what happens? Well, you fall 15 feet And as you fall past this thing, you say, gee, I really hope that I put that in there and that it really was stuck in that crack, yes? And then you fall another 15 feet. You've now fallen 30 feet, and you hit the bottom of that rope, don't you? Your harness, you're like, boom, you hit that thing. You stop going down. Well, how much force do you exert when you stop going down? Here, let's just do a little experiment here. Let's try this, right? This thing is falling. Let's have it just fall just a short distance. How much force is it? How big was that force? Yeah, it was like really big. Here it's like, oh, there we go. In fact, it went all the way around. In fact, now it's not calibrated or something, right? Yeah, it can get really, really a lot of force, and that's why, of course, climbing ropes are very strong. Yes? Now are we ready for the unwise story? How common is it to fall? Well, I don't know, right? But that's why you have it, so that you can fall and that it will hold you, right? Now, story time. Are we ready for story time? Okay. I don't know if I should stop the camera or not for the story. Okay. But anyway, here's the story. Okay. I am in the third floor of my dorm. It is January. It is 1986 or 87. And our dormitory was co-ed by floor. So this was boys, girls, boys. Okay. I was living in the third floor because I was a sophomore. Freshman year I had to be in the basement of Dayton Hall. But by my sophomore year, you know, I'd moved my way up to the top floor of Dayton Hall, which, by the way, now is a parking lot. Isn't that sad? They paved they paved over my dorm. You know, I know. There it is. Right? Okay, so there I am in the study hall, and I am doing my labs, not because I'm a dedicated physics student, but because I've made a list for myself. Do you guys make lists? How many people make lists for yourself? Yes, how many people put things on the list that you've already done so you can then cross them off? Yes? How many people put things on the list that are rewards? Do your homework, then do this thing, like, I don't know, whatever it is, right? And then, right? Yes, do you guys do that? Yeah. I do that. And my reward for doing my physics labs, which I didn't like, was that I would go to Raiders of the Lost Ark in the cinema. Yes? Isn't that a good reward? Yeah. Yes, so I was at this point. Isn't this a good point? It's 6:45. The movie's at 7 o'clock. It's 6:45. I'm doing this. Isn't that good? Is that good? Yeah. That is good. It's the only thing that's better than this is this, right? Isn't that good? That's definitely really good, isn't it? Because that's like, then the next thing is you just turn it in, right? Right? So there I am. I go to the door and I go to open the door, right? And I get to the door, and the door does this. So this is, if this was a college dormitory door, okay, we would be outside the door, okay, actually. But I go to the door and I go, and I can't turn the knob. And I know immediately what somebody has done. What they've done is they have pennied me into the room, okay? So I need Nick. Nick, come up here. Nick's going to help me. He's going to penny us. We are, by the way, outside someone's dorm room, because dorm rooms, the doors always open into the room, because obviously you don't want them opening into the hallway. Okay, and I just picked you because you look like you might have strong legs or something like that. Okay, and what you're going to do is you're going to push on the bottom of the door really hard. Okay, and I'm going to take something. Usually pennies are good. You can take a stack of pennies and use a stack of pennies. I'm just going to take this little wedge here, okay, and push hard on that bottom of that door there. So right just on the bottom, just with your foot. Just reef on that thing. Okay, there we go. This is good. Okay, let's see if we can get that in there. It's there. Okay, that's good. Now, if these were pennies, what you'd want to do is you'd want to get the pennies. See how I've got that thing wedged in there? The door is warped that way. Yes, it would be warped into the room. You really want to get a stack of pennies, as many as you can, and get them about 4 inches below the latch, right? And do a tremendous stack of pennies so you can barely wedge them in there. And the bottom of the door, by the way, what you do is you can put down that. Okay. The person lies down on the floor of the hallway and they do a leg press, which generates considerably more force than we could do here. And you actually bend the door until it starts to crack. And they're solid wood doors. They're these sturdy wood doors for fire purposes, right? And what happens now is the door is warped. Now listen to it. This thing's not going to be, we're not pennied in because this is a big latch and we didn't do that good a job. But listen to the latch as it slides out. Listen. That's kind of weird, isn't it? Yeah, why is it doing that? Well, because we warped the door and the door is now straightening out, right? If we warped it